Okay, so here we are. We're going to be doing the stoichiometry lab. This is the copper carbonate. I masked an empty test tube. All right. Then I put the 2.00 grams of copper carbonate in there. So I have this data, which I'll share with you in a few minutes. The test tube by itself was 31.69 grams. Then when I added the copper carbonate, which is this green powder, to it, it was 33.69 grams. All right. So I have 2.00 grams of copper carbonate in here, and I'm going to heat it up and produce copper oxide, which is the product here. All right, which we want to produce copper oxide. It's used in the semiconductor industry, so we want to make product. So I'm going to, by heating this up, decomposing it at high temperature, it'll break down and form into copper oxide and carbon dioxide, which will go off into the air. So I'm going to light the lab burner. Again, what I want to do is get a very hot flame. So right now I'm burning just gas coming out, natural gas. So I'm going to open this up so that a little hole here, air can come through with a little gap at the bottom, and I get a bluer looking flame instead of that yellow. And I'm going to make it a little bit bigger. And what I want to do is bring my test tube, which I've already clamped in place here. I've got it sideways. I've got it over here so that the flame will be over here. All right, so as I'm heating that, it will get hotter over here, but not over here. All right, let me see if I can zoom in. All right, so let me get a little bit closer look at that. So, as we're heating this up, now I'm going to start bringing this down. I start heating gently at the beginning, and then gradually lower it down into the flame to heat it more strongly. And I'm also going to turn the barrel so more air can come in. And now it's a little hard to see, okay? But if I stand up here, you can probably see the flame better. All right, so you can start to see that it's turning black here. It's turning black. That's the copper carbonate. It's decomposing, breaking down and making copper oxide. Interesting, I don't know if you can see this, but up here, there looks like there's some water moisture. It looks like water vapor coming off. So that's interesting. Right? See if I can, I'm going to turn this for you to see a little bit better. Right in here, in this area here, there's a whole bunch of, looks like water on there. I'm going to take this, and what I want to do is kind of mix it up a little bit. I want to distribute that copper carbonate in there so that it all gets heated. So I kind of jostle this a little bit. And I want to move my burner so the very tip of the flame is there. Yes, that looks like water moisture. I don't know if you can see that. Again, I'll see if I can zoom in a little closer on that so you can see that. But all this looks like condensation there. Let's see if we can zoom in. All right. Well, it seems to be, yeah, it's, if you look right in here, it's all what looks like liquid water. I'm stirring this up. A lot of it's black. I see very little green there. All right. Let's turn off the light so you can see what this looks like. It's out. All right. Let's see how that shows up. All right. So I've got a nice hot flame. I want to see that little cone, the tip of that flame. I want that to be right there. Right there. Yeah. And I'm going to kind of mix it up. I also want to go up here and heat up here where I see this moisture, this liquid, whatever this liquid is. I don't want that in the test tube. See, what's going to happen here is, and it looks like maybe I need to turn on my lights a little bit. It looks like the liquid moisture there, I've got to heat that up. So what I'm going to do here is I'm going to eventually evaporate off that liquid, because I don't want that. I'm interested in the product here, the copper oxide that I'm making. And once this cools, then we'll get the mass of it. Okay, we already have the mass of the compound that we started with. We know we have 2.00 grams. From our calculations, our stoichiometry calculations we did yesterday, we calculated that 2.00 grams of this, when it decomposes, will produce 1.2 0.29 grams of the copper oxide. So I'm interested in how much I'm getting. I'm interested in what's called my yield, my percent yield. All right. So let's come back. Turn the light on for a minute. A little bit better. And I'm going to just keep mixing that up a little bit. And so, as I said, I'm really interested in the yield of that. And the yield is the actual yield will be how much I actually produce once I've stopped heating this. Once I've stopped heating this, which I'm going to go about another minute because it looks pretty good, and I'm going to let this cool off. And once it's cool, then I'm going to measure the mass of it, and then I'll put it in the data table. Once we have that, we'll know how many grams of this we made, and we can compare what we actually made, which we call the actual yield, with what we thought we were going to make, the theoretical yield, which is the 1.29 grams. So we'll see how we do it in terms of our percent. And the formula in your lab sheet tells you how to calculate the percent yield, which is the actual yield, which will be how much we actually made, divided by the theoretical yield, the amount we were supposed to get, which is 1.29 grams. And you multiply that times 100, and you get your percent yield. As a chemist, you want to have the highest percent yield possible, which the highest would be 100%, right? But, sometimes stuff happens. We maybe spill some, or we lose a little, so we maybe only get 90% yield. But the higher our yield, the more money we're going to make, because we're going to sell this. You can sell this product. And so you want to get as much, you want to have as much of the starting material, as all the starting material, you want to convert it to your product. You don't want to lose 50% of your product, or 50% and only get 50% of the product out of this. All right, you want to get the whole thing, all right? Because it's money when you sell the product. All right, so I'm going to shut the gas off here. I'm going to let it cool down, and we'll resume later.